Hi students, welcome back to the channel. Today's topic that we are going to see is how to solve or how to write an algorithm, how to write the pseudocode for an algorithm. Previously we have seen the Euclid's algorithm and we have solved for GCD 60,24. Today's class we will be seeing how to write pseudocode and algorithm for the given problem. So there are several steps that we have follow while writing an algorithm. The steps will be like this: step 1, step 2, step 3. Step 1 is, if n is equal to 0, return m as the answer and stop, otherwise proceed to step 2. What is the step 2? Divide m by n and assign the value to the remainder of r. Step 3, assign the value of n to m and value of r to n and go to step 1. So now the last step is nothing but it just clearly says that you have to replace the old n becomes our new m and our remainder becomes our new n. Okay, remainder becomes our new n. So let us take one example and solve and how to write how the iteration of the algorithm works. So the iteration 1 means step 1. Okay, so how the computer solves this and how the algorithm is being checked. Let me remove all the other things from the screen. So the iteration 1 will be, let's take another example, say GCD of 18,12, where m is equal to 18 and n is equal to 12. What does the step 1 says? It will check whether n is equal to 0, right? So n is equal to 0, that is a condition. Is n is equal to 0 is a question mark, so it is not. So what it says, proceed to step 2. What does the step 2 says? We have to divide m by n, right? That's a simple division technique that we have done it. So 12, 18 and it is 1s are 12, so you get the remainder as 6. Okay, so now what you have to do? So remainder is 6. Now what you have to do? You have to assign the value of n to m, and the step 3 is value of r to n, right? So what does that mean? Okay, what does that mean? Our old n becomes our new m, our remainder becomes our new n, right? So it is nothing but 12,6. Now iteration, so it is nothing but our old n becomes our new m and our remainder becomes our new n, right? Now it will go to step 1. Okay, step 1 or the iteration 2. Iteration 2, what does it say? So now the new m is 12 and the new n is the remainder, that is a 6, right? Now it will check whether n is equal to 0. Answer is no. Again the step will repeat, right? Step will repeat. So what does this step is? M divided by n, right? It is 6 divided by 12, that is nothing but 2's are 12, so you get the remainder as 0. So remainder r is equal to 0. R is equal to 0, and now the old n will be the new m, that is 6 comma the remainder 0. Now again the step will be repeated, right? The step 3 will be completed. Now it will go to step 1 again. Iteration 3. Now the new m is 6 and the old n is 0. The new n is 0. So it will check whether n is equal to 0. The answer is yes. The iterations will be stopped, correct? It will be stopped and it will come out. So it will return m is equal to 6. So just like that, we found the GCD of 18,12 is equal to 6. It's super efficient because the number gets smaller very quickly with each step. All right, now we will go and write another way, or how a pseudocode looks like. So which is just a more structured way of writing down algorithm for a computer. Okay, we are writing the pseudocode. Okay, so how to write a pseudocode? The pseudocode writing is very simple. So first and foremost thing what you have to do is you have to give a title or header, okay, which clearly state the name of the algorithm or the function. So what is the name of the algorithm? It is Euclid, that is m comma n, and you have to, it's optional, you can include the comments or you can skip the comments, but it is a traditional way of writing the pseudocode. So optionally you can include the comments to explain its purpose, and you you should also include its input and output in the comment section. So the first will be your comment of what the algorithm is about. So you are going to compute the GCD of m comma n by the Euclid's algorithm. So what are the input and what are the output you are going to give? So what is the input that you are going to give? That are the two numbers m and n, right? Two numbers m and n which are non-negative and not both zeros, right? Not both zero integers, that are m and n. Okay, so what should be the output? Output is nothing but the GCD, right? The GCD, or the greatest common divisor. So don't write the write it in a full form. Don't just write the GCD, so that it's a pseudocode you are writing, so that everyone the reader who reads it should understand it. So the greatest common divisor of m and n. So now we are going to write the logic or the body part. So actions that happen one after another, each action typically gets its own line, right? So while n is not equal to 0, that's a condition, right? We have to check every time. While n is not equal to 0, what you have to do is the remainder is nothing but the m mod n, right? The remainder is nothing but m mod n. And what happens once this is done? The new m will be our old n, right? The new m will be our old n, right? So you replace n by m and you replace our old n with the remainder. Okay, now until when it repeats, until the while loop gets false. Okay, it will come out. So once it is false, what you have to do? You have to return m. Okay, so this is the all about how you write an pseudocode for an Euclid algorithm. Now let us see another example. Second example that we are going to see is a consecutive integer checking algorithm for computing the GCD of m comma n. Okay, we will dissect the steps as we go on solving the taking one of the example. But let's say that I have taken two numbers, say 20 and 30, and I am looking for their GCD. We know that GCD can't be bigger than the smaller of the two numbers. Why? Because if it were, it couldn't possibly divide the smaller number, right? So for 20 and 30, the GCD must be 20, or it should be lesser than the 20 number. Okay, it should be lesser or 20. It should be 20 or lesser than 20. Okay, what if we just started checking the numbers? So the numbers will be starting from 20, it goes on 20, 19, 18, 17, 16, so on up to 1, and it is going backwards or downwards. The first number we find that divides both 20 and 30 perfectly. Okay, that will be our GCD, because we are checking in descending order. The first one we will find automatically be the greatest. All right, now suppose let me read the algorithm. The algorithms look something like this. So I will remove everything and let's dissect one by one. Let me zoom out so that I can take the algorithm on one hand side, and let's solve the iteration on the other side. Okay, so what I am taking, m is equal to 20 and n is equal to 30. Okay, here one extra term you can see is something called as t. So what is t? T is nothing but the minimum value, right? So the minimum value of 20 and 30 is 20. So we set the t as equal to 20. So what we have to do now in the step 2? Okay, so 20 will be our test number, and we are starting our search from the largest GCD possible. Okay, in the decreasing order. So step 2 will be we divide m by t, right? If the remainder of this division is 0, then go to step 3, otherwise go to step 4. So what is m now? M is equal to 20. So m is equal to 20. I'll write it down. M is equal to 20 and t is equal to 20. Okay, m is equal to 20, t is equal to 20. So is 20 divided by 20 is 0? Yes. So the remainder of 20 divided by 20 is equal to 1 with the remainder of 0. So since the remainder is 0, we go to step number 3. So what does step number 3 says? Divide n by t. If the remainder of this division is also 0, return the value of t as the answer and stop. Otherwise, proceed to step number 4. But here what we have, remainder is equal to 10. So we will go to step number 4. It is not 0. It is step number 4. What does step number 4 says? If the remainder is not 0, decrease the value of the decrease the value of t by 1 and then proceed to the step number 2. So now what we have to do? Okay, we have to proceed step number. So we are proceeding to step number 2 now, right? So what now we have to do? Yeah, so decrease the value, we decrease the value. Now t is equal to 19. So now the iteration we are doing is for iteration number 2, for the value of t is equal to 19 and the value of m and n should be 20 and 30. So step 2 will be what? Yeah, t is equal to 19 and m is equal to 20. So what we have to do, as step 2 says, we have to divide 20 divided by 19 and check whether the remainder is 0 or not, right? So what answer we will get? So when we try to do this, 20 divided by 19, I am going to get the remainder is equal to 1, right? Remainder is equal to 1. So it is not equal to 0. If so what does step 2 says? If it is not equal to 0, then you are going to step number 4 and decrease the value of the t by 1 again, right? So iteration number 3, what does iteration number 3 says? So I'm going to step number 4 now. What does the iteration number 3 say? Iteration number 3 says t is equal to 18, 20 divided by 18, remainder is equal to 2 and it is not equal to 0 again. So again we are going to step number 4, right? What is step number 4? Okay, so step number 4 will be, iteration number 4 will be what? T is equal to 17. So 20 divided by 17, the remainder I am going to get is it is equal to 3. So I am again not getting the remainder as not equal to 0. So on and so forth. You have to continue this iteration until you get 0. So what I will do is I'll fast forward. You can check for all the numbers and check whether you are getting the remainder as 0 or not. You will not get until you reach the number, say t is equal to 10. So I'm going to iteration number 10 where t is equal to 10. So when I do this, 20 divided by 10, I'm going to get the remainder as 0. I'll go to step number 3. I'll divide 30 by 10, right? What the step 3 says? If it is 0, go to step 3 and divide n by t. So what is that? 30 by t, that is 10. I'm going to get the remainder as 0, right? So here also I'm getting the remainder as 0. Yes, now what I have to do, once I get both the answers as zeros, then return t as the answer and we have to stop it here, right? T is equal to 10 now, right? So what is the answer? I will stop it. So what does say? So if the remainder of this division is 0, return the value of t as the answer and you have to stop. So GCD of 20 and 30 will be is equal to 20 and 30 is equal to 10. So we found it. It took a few tries, but we got there by systematically checking every number downwards from the smaller of the two inputs, right? So now let us see what is the pros and cons of using this technique. Okay, we have to know why it is important, right? So pros is, it is very simple to understand. The logic is very intuitive. You just checking the numbers from top to down, easy to implement. It's straightforward to write code for this. Now what is the con is it is inefficient. This is big one, right? Imagine finding the GCD of 999 and say like 1,00000. So what you would be doing, like you would be start checking from 999 and you go all the way down, and that's lot of division, right? You have to do one at a time. So this is so it's like 99999 times you're going one by one. It is taking a lot of time for you. It is often requires many more division operation compared to Euclid's algorithm, especially for the larger numbers, right? So this is precisely why Euclid's algorithm is usually preferred in computer science. It's much faster because it reduces the numbers so much more rapidly by using the reminders, right, rather than just decrementing one at a time, right? It is faster, right? So the consecutive integer checking algorithm is a good example of the brute force approach. So it works but it's not always the smartest and the fastest way. So brute force, so I'll write it here. So it is a brute force approach, that phases or technique. So what do you mean by brute force technique actually? So brute force attacks, have you heard in your have you heard ever attack? So brute force attack is nothing but suppose you have password of length 4, say ABCD is so it's all the characters that you use in your password. Then what the attacker will do, first he will try with the capital ABCD, then he will try to change one character, and then he will go on doing another character, and so on and so forth. So this is one at a time, so right, one time he will decrement, or one time he will change the character and he will go on using it. So that's what brute force attacks mean. So here it is similar to that of brute force technique, because we are decrementing by 1. Next, so we will see algorithm design and analysis process in the next video. Thanks a lot.